Hello all and welcome back. So in this video, let us continue our discussion on trees and now let's try to improve our print tree function. So in the last video, we saw that though we were able to print each and every node of my tree, there was a problem because multiple trees can have the same output. So I cannot be sure that the tree which is getting printed that is unique. Like my tree is exactly the one which is being shown by the output. Something which of course we will be requiring, right? So let me actually draw a new let me define a new function only. Define print tree detailed. Okay. And we will be getting the root. Now, one thing note to notice more everyone, in the last video, we used recursion, but here we have not used the base case. Okay. So you will see that we have not written any base case. Why exactly is that happening? You can maybe pause the video because again, we have done recursion pretty nicely. Great. So if you would have paused and thought on this, base case actually is automatically getting handled here, right? Because I'm doing this root dot children. If there are 0 children, it is not going to run. Okay, so the base case would have been something like that. If children's are 0, then just print the root and go back. So base case is getting handled here. But I still have to make sure that if someone sends me root which is none, okay, so something which we saw, then I cannot make an error like this. So let me actually show you the error. Okay, so someone sent me like just a empty tree. And see, we know this error. 1 second. Let me write pass here for the timing. Yeah. We know this error, right? It's saying that, hey, none type object has no attribute data. So this is actually a edge case, which I would like to say that, hey, if your tree is empty, then please just return. Okay, something like this. Now, why is this an edge case and not a base case? Because when I try to run my recursion, it will just handle case when my root is none. I will never be coming to this particular case via recursive calls. And if you have understood recursion pretty well from this overall course, then you would know that base case was the one which we used to hit towards the end. But here, this is the edge case. Okay, so please make sure that this kind of understanding is also clear. A lot important with respect to coding and interview point of view. Okay, so we have to make sure that we handle this edge case, right? Okay, so now let us move forward, everyone, and see how we can do the printing pretty better. First thing is, let us just copy this. Again, the edge case is going to be here as well, right? Cool. Now let us see how exactly can we print our tree in an easy way. So what I would want, okay, what I would want my output to look like is something like this. Let me draw a tree. Let's say if my tree is the one which we were seeing. So it's 1, 2, 3, and 4. Right. So this was the tree which we were working on. Effectively, I want the output to be something like this. I should get 1 and I should just get all the children's as well. So 1 has a children, 2, 3, 4. 2 has no children, 3 has no children, 4 has no children. Again, I'm printing the notes as it is. That is not a problem. So this part is as it is. I just want some more extra information. Okay, so let us see if this will be different for the different case I discussed to you about. Let's say this is my 1. Now I have this node which is 2. Okay. 2 again has a children which is 3. And finally I have a node 4. Okay. Great. The output here should be something like this. 1 has 2 children which is 2 and 3. 2 has no children. 2 has 3 as children. 3 has no children. 4 has no children. Okay. So yes, we are able to see that the output is different. Again, everyone, these are the very small things which we need to take care of. The more you will be handling these things right now in your code, the better program you will be writing going forward. Okay, whenever you are working as a software developer, you are developing something, you are making, let's say, your own AI application, the way you handle the messaging, the communication of your app or your website, or even your errors will be a lot better. So these kind of things are a lot important to pay attention to. Okay, great. So now let us see how we can do it. Okay, one thing which I can see and I'm going to implement is that I see that they are the same children, right? These are the children of my one. So before I'm calling recursion, maybe I can just use another loop where I'm calling on each and every of this child of one. In a similar matter, one, we have two and three as child. Then for two, we have three as a child, right? So great, everyone. Let us see this. All I have to do is for first I have to print, and in print what I have to do exactly is root dot data. Because I have handled this edge case, I'm sure that I will never face this error, right? Once I have this root dot data, then next is going to be okay. Let us just actually try to build that answer. So now for each child in root dot children, okay, I just have to print these children as well. Sorry, each second, yeah, each child dot data, right? To make sure that it doesn't go into the next line, I think we should have this end like this. So not really sure why it's coming. Yeah, we should have some end which is like this. So we have already discussed this how print are having two, three parameters which we can play with, separator and end, right? And now I can just call the way I was calling. Now I can just call the way I was calling. So that sounds good. Yeah. Just one thing more, which I feel should be there is that let me first print it for all of you so that we can build on that answer as well. Let me zoom out actually. Yeah, cool. So let's say I call this print read detailed. Okay. I will first explain you what exactly have we done. So pay attention, everyone. What exactly have we done is we have checked for the edge case. That is fine. We have printed our root data. So one will get printed. Then we are printing each of these children, right? So they should get printed something like this. And then I'm calling recursion on the overall subtree. Again, you have to make sure that you handle your printing well for your root. If you're able to handle that well, then recursion is going to do its job. That is something which we have now seen a lot in recursion, right? If you do your work properly, recursion doesn't have any problem. Okay. So yeah, let us print this once. Let me pass root here. Let me run this. So yes, we are getting something, but I think this is not the right output. Okay. So some small things we have missed, which is that after this one, it should not go to the next line. We should have something like end is just this thing. Okay, so don't go to the new line, please stay here. Rather, I should make end like this so that we have this here, the colon here. Great. And in this as well, we should have some separator, which is like this. Okay, so let us try to run this now. I hope you understood exactly. Now, this is a stuff which we would have discussed a lot initial in this course, how these are some parameters of my print function. So let me now print this. Again, we see that some problem has happened. We have not actually changed end, so that's going to be a problem, right? Let us make end like this, and separator will actually not get used because we are printing them one after another. So let us make end like that, right? And once I've done this, let me just print a new line. Great. So now I feel it should be right, as we can see. Now this extra, of course, we can take care of. That is not a problem, right? This extra thing I can of course take care of. So we are able to see the output, I think, right? It is one is having two, three, four as children, two no children, three no children, four no children, right? If we want, actually, we can have the F formatting and everything here, so that is not a problem. To make sure that we are controlling each and everything, that should not be an issue. Maybe we can just have this end like this, and if I run this now, then you will see that okay, how exactly is this happening, right? So I'm just printing the root data, and yeah, I think this works. Just one thing we have missed. It should be print read rate, not this. Yeah. Now we will see it like this as well. So I was just wondering that why we are not seeing this colon overall. Okay, great. So let us do one thing pretty nicely and quickly. Let us just make these children. So we have this root now. Okay. instead of appending 3 to child 1, let me just do this thing. Okay. So now let us see how this tree will be like. Let us understand this quickly. We will have a root node which is 1. In 1, first add a children 1, child 1 is 2. Okay, so see, child 1, child 1. We are appending it. In child 1, append child 2. It should be 3. In root, append child 3. Child 3 is 4. 4. So we saw that how this was giving the same output, and I can maybe show you that as well. So just give me a second. Let me remove everything. Yeah. If I try to print tree, okay, and this particular tree, like we have reinitialized everything. Let me move this. If I run this, see, we are getting 1, 2, 3, 4 only. Okay, but we know that this tree is not having the same structure. This tree and this tree, again, same output. So just to make it a little bit better, print it. And now it works fine, right? 1, it has 2 and 4 as children. 2 has 3 as children. 3 has nothing. 4 has nothing. We have handled the edge case pretty nicely. This has been handled pretty nicely. And we are making sure that we are calling on each and every children when it is there. So just if I remove this as well, see how nicely these trees are now distinguishable. Okay, everyone. So again, just a small tweak, but the same is helping us a lot in identifying our tree rightly.